All right, everybody, welcome to the video for the review of the benchmark exam, benchmark number 2. So for benchmark number 2, it's going to have some parallelogram questions on it, some triangle proof questions on it, and a bunch of similarity. So basically the last 2 units. So let's take a look at number 1. So it says if triangle ABC, if quadrilateral ABCD is a parallelogram, which statement would help you prove that it is a rhombus? To prove something's a rhombus, there were 4 things that are special about a rhombus. A rhombus is a parallelogram. A rhombus is a parallelogram with 4 congruent sides. A rhombus is a parallelogram where the diagonals bisect the angles, and the diagonals are perpendicular to each other. So I'm looking for one of those things here. Opposite angles are congruent, because if you draw the parallelogram and call it A, B, C, D, ABC would be this angle, CDA would be this angle. That doesn't prove it's a rhombus, it just proves it's a parallelogram. AC and BD being congruent, those are the diagonals. In a rhombus, the diagonals aren't congruent. That's only in a rectangle and a square. The diagonals are congruent to each other. That's a rhombus trait. Perpendicular to each other. And AB and CD being perpendicular to each other, AB and CD being perpendicular, that doesn't make sense at all. That's not even going to be a parallelogram. So the only thing that makes sense here is that the diagonals are perpendicular. The next one, because a rhombus not only is a parallelogram, meaning that these segments are congruent, they also have congruent 90-degree angles in the middle, which is going to create right triangles. Right triangles are always important because if I see right triangles, I can use the Pythagorean Theorem to solve for missing sides. So if PR is 16 and it gets cut in half, each of these little pieces is 8. If QS is 30 and it gets cut in half, each of these little pieces is 15. So if I just take one of these triangles, doesn't matter which one, and one side is 8 and one side is 15, I can use the Pythagorean Theorem to find the missing side. And we can see that that comes out to be 289. Square both sides, and we get C is equal to 17. Now, 17 is not your answer, right? If you look on the answer sheet, 17 is not the answer. But what we just figured out is that one side is 17, meaning since it's a rhombus, all of the sides are 17. So if I wanted to find the perimeter of this, it would be 4 times 17, which is 68. The next one is the side splitter theorem. So understanding that the sides here are being cut into pieces because of this being parallel to this. And it tells us enough information to figure out MO is 6. And it wants us to find TR. So I could say 4 compares to 6 the same way that X compares to 9. So you get 6X is equal to 36, or X equals 6. Under which transformation would A prime, B prime, C prime, the image of triangle ABC, not be congruent? Now, the only thing that we did in this entire course where it was not a congruent relationship were dilations. So I'm looking for dilations to be able to see that. Which is not enough to prove that the triangle is a parallelogram. There are a couple different ways of proving a parallelogram. We had the 5 traits of a parallelogram, or if one set of sides was both congruent and parallel. So if I look at choice A, I see one set of sides, AB and CD, are both congruent and parallel. That does prove a parallelogram, so that's not my answer. Choice B is that both sets of opposite sides are congruent. That's a trait of a parallelogram, so that's not true. C says that AB and CD are congruent, and then BC and AD are parallel. That's not something that proves parallelogram. If you think about it, I could redraw this picture labeled the same way, make it so that the top and bottom were parallel, and that the two sides were congruent and making an isosceles trapezoid, that's not a parallelogram. That's what C is saying. These opposite sides are parallel. That's good. That's a good trait of a parallelogram. The next one is something that a lot of you I saw was getting wrong when you were trying this in class or after school for help. So if you label this picture, DB is 12, DE is 4, I want to find AC, and I know that AD is 24, meaning this entire piece is 36. Now remember, when the bases are given or labeled and you're trying to find them, you have to redraw your triangles. Don't be lazy. Some of you are being lazy and not redrawing the triangles. Because once you redraw the triangles, you notice you're not going to use 12 and 36 and 24. You're going to have to use this 36. It's important. Because 36 is what becomes 12 and x is what becomes 4. So then I can say x over 4 is the same thing as 36 over 12. So now I have 12x is equal to 4 times 36, so 144, divide by 12, and I get x equals 12. Number 7, which cannot prove similarity. So to prove similarity, we're looking for the angle-angle relationship, side-angle-side relationship, where the two sets of sides are not congruent, but they're proportional, or the side-side-side relationship, where all of the sides are proportional. So if I look at choice A, I see the side-angle-side relationship forming. I just have to make sure that the segments that correspond to each other are in the same proportion. 4 becomes 12 by multiplying by 3. 3 becomes 9 by multiplying by 3. So we have the side-angle-side relationship, and we have proportional sides, so we're good. B is angle-angle. That's the most obvious one. C is angle side-side. We don't want that. That's no good for us, right? Oh, I shouldn't even write that. That's a bad word, right? So we can't put that up there. So C is my answer. D is the kind of distracting answer because you're looking at it and saying, well, those aren't similar, they're congruent. Well, congruent triangles are similar by a scale factor of 1. So that's kind of just like a weird distracting answer. Number 8, in a parallelogram, the diagonals AC and BD intersect at E, which statement does not prove it's a rhombus. So again, to prove something's a rhombus, you're looking for the sides to be congruent, the angles to be bisected by the diagonals, or the diagonals to be perpendicular. Okay, so if I just draw a rhombus, A, B, C, D, you can even draw in the diagonals here at point E. So it says that AC is congruent to DB. That's never going to be true for a rhombus, so that's the answer. Meaning the other 3 choices must be true, right? Remember, a rhombus does not have congruent diagonals. First thing I would do here for number 9, once I see the picture, it looks like the 2 triangles are different sizes. So I want to see if they're similar or not. I already see one set of congruent angles here because of vertical angles. If I find the supplement to 115, it's 65. So now I see 2 sets of congruent angles. So these 2 triangles are similar to each other. And if I look, the segment that matches 15 is matching 6. Those are corresponding to each other. If you don't believe me, rotate around triangle ADC. All right, if I rotate around triangle ADC, it would be a picture that looks something like this, where C would be here, and A would rotate all the way around to here. So I'd have a 6, and then I'd have a 15 like this. And then if you look, it's kind of like that type of problem we've been doing with the side splitter theorem. All right. Now they want us to find the length of CB. So CB is here. So 6 compares to 15 the same way that 4 compares to x. So I can set up a proportion. So I can say 6 over 15 is the same thing as 4 over x. do some cross multiplication. So I have 6x equals 60, or x equals 10. Number 10 is another one of those side splitter theorem questions. It's just asking is this parallel or not, though. All right, we actually did this one in class. It was in the notes. So one of the things that we were able to say was, if this relationship is the same as this relationship, the triangles are similar, forcing the two segments to be parallel to each other. So we just have to see if it's the same relationship. So if I do 3.75 over 5 is equal to 4.5 over 6, if we cross multiply, we can see if those answers come out to be the same. So if I do 5 times 4.5, that's 20 and 0.25, 20.25. And if we do 6 times 3.75, that also gives us 20.25. It's the same thing on both sides. Therefore, they're proportional. So we can say AB is parallel to CD. It says explain, so I have to use words. Because the sides are proportional, making the triangles similar. Number 11 is a proof. It tells us it's a parallelogram. This is an enormous amount of information. We know that the opposite angles are congruent. We know the opposite sides are parallel to each other and congruent to each other. There's a ton of info here that we need. Now, to prove similarity, we just have to prove two angles. So if I just have to prove two angles, I want to look for one right away in the picture. There's usually vertical angles or something there, and I see that here. So I could say this is angle 1 and 2. Now, without really doing any info from the givens, I know those are congruent because they are vertical angles. Next, I'm going to write the given. So I'm going to say A, B, C, D is a parallelogram. That's given. Now, if it's a parallelogram, that tells me that this side and this side are parallel to each other, meaning this transversal should create alternate interior angles for angle 3 and angle 4. So I can say AD is parallel to BC because in a parallelogram, opposite sides are parallel. And from that, I can then say 3 and 4 are congruent because of alternate interior angles. And then from these two statements, I could say that triangle DEF is similar to triangle BGF by angle. The next part here asks us to describe the transformation. So if you look at A is the coordinate of -2, +4. A prime is the coordinate of -1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -5, 10. B is -2, -4. B prime is -5, -10. C keeps popping up. C is 4, -4. And C prime is 10, -10. Now, I definitely noticed that the size changes, so I know this is going to be a dilation. I just want to be specific with my dilation, right? Am I dilating a lot, a little, more than one, less than one, etc. Right? So I can even figure out what the scale factor is. So to find the scale factor, if I take the dilated number and divide it by the original number of any x or y value, I should get the same value. So if I take -5 and divide it by -2, I can figure out that the scale factor is 2.5. So when it asks me to describe the transformation, I'm going to say a dilation about the origin of 2.5. Then I can say the triangles are similar because dilations preserve angle measurement. So if angle measurements are the same, that means the angles are all the same, thus angle proves similarity here. The next one, angle S is 60. Angle SRT is 83. Well, I know angle S and angle R, since this is a parallelogram, are supplementary. I know that they have to add up to 180. So if I take 180, subtract angle S, and subtract the part of angle R, I should be able to figure out what's left here, right? So I'm going to be left with, let's see here. So if I take away the 60, I'm left with 120, so that's 37. So this little angle in here is 37. The next piece of info says TWU is 35, making this angle here 35 because of vertical angles. Meaning I can find angle WVR. I know that's not what I want, but it's adjacent to WVR, so then I can kind of go one more step. So if I take 180 and subtract 35 and 37, well, that's 72, so I'd be left with 108. So that means 108 is here, making this angle that they want 72 because they're supplements to each other. The next question asks us to determine which of those would create a similarity situation here with side, angle, side. So the angle that we want to be congruent is going to be angle A and angle D. Otherwise, it wouldn't be side, angle, side. So right away, I can cross off choice C and D. I don't even have to look at those choices. Now, if I look at choice A, if DE is 9 and DF is 12, the scale factor to get from 6 to 9, will that be the same as 8 to 12? So if I do 6 compares to 9, is that the same thing as 8 compares to 12? So 6 over 9 reduces to 2/3. 8 over 12 reduces to 2/3. So that works. So that first one is good. If we were to do the second one, when I reduced it, it wouldn't give you the same ratio. So that would be an invalid similarity. Rectangle. Special properties of a rectangle is the angles are all 90 degrees and the diagonals are congruent. So diagonals are congruent is a choice, so that's the answer. The next one, so if we know that those two segments AF and DF are congruent, I know that AFD is an isosceles triangle. Also tells us that Fred is a parallelogram. So if angle R is 124, I know angle D is 124. Well, if I take 180 and subtract 124, that gives me 56. So I know that little angle is 56, and because of the isosceles, I have 56 there as well. And since it wants angle AFD, AFD is this angle up here, I know that all triangles, if you subtract 180 minus the two angles, so we're subtracting 112, so that's leaving us with 68. There definitely is one proof on your benchmark exam on Thursday, tomorrow. Now, I'm not saying it's similar to this one, but it's got a lot of same concepts here. So it asks us to prove two angles are congruent, angle ACD, and angle CAB. Now, I don't actually need to even prove triangles are congruent here because of this. So if I know that it is a parallelogram, I know the opposite sides are parallel. So I know that CD is parallel to AB, because in a parallelogram, opposite sides are parallel. Why is that important? Well, if this segment is parallel to this segment and this transversal cuts it, I know these two alternate interior angles are congruent. And those are the angles I want. So then right off of that bubble, I can say that angle ACD is congruent to angle CAB because of alternate interior angles. The last question, these are always tough, which is always true. Now, in the picture, it looks like there's a lot that's true. It looks like there's a lot that's true here, but you have to kind of take it piece by piece. So it totally looks like BC is right in the middle of A and E. But it doesn't have to be. It doesn't have to be a dilation of 2 or 4 or whatever you think it might be. I could have made it so that this is here. That would still be a dilation. It wouldn't cut that segment in half. By doing that or understanding that, that eliminates choice A and C. Now, the one that a lot of you chose on your last test was choice B. And that's because it totally looks like AD and ED are perpendicular to each other. And they might even be perpendicular to each other. But if I was to expand this to make it so that they weren't perpendicular to each other, would those two triangles still be dilations to each other? The answer is yes. So the only thing that needs to be true for these to be dilations is for these two segments to be parallel to each other. No matter if I draw it really small up top or really big on the bottom, or if I expand out D, those are always going to remain parallel to each other. Hopefully this video helped you understand what's going on. I think this is the last question, right? Yep, it is. So make sure that you're studying, look at this video, look back at your notes. This video doesn't encompass everything that's on your test. All right, so you have the whole day here, you have no school, so I'm hoping that you're using this time efficiently for you to be able to study and prepare for your benchmark exam tomorrow. Remember, no matter what happens with delays or anything like that, you will have a benchmark exam tomorrow. Good luck studying.